welcome to another session of the Transform Your Business webcast series. Today's webcast is Securely Connect Any Control System to the Cloud with IoTWorks. My name's Amanda Gordon, and I'm the Senior Marketing Programs Manager here at Iconix. Before I kick things off today, I just want to go over a few housekeeping rules. Right now on the webcast, you are in a listen-only mode. That means if you have any questions at any time throughout the webcast, just type them into the GoToWebinar questions section, and we will answer those at the end of the webcast. Now let me introduce you to our three presenters for today. We've got Tom Buckley, IoT Business Development Manager, who works in our headquarters in Foxborough, Massachusetts in Iconix. We have Bhargav Reddy, who is a Solution Sales Engineer here at Iconix. And we also have a special guest speaker today, Nathan Smith, who's the Channel Sales Director of North America at Advantech. And with that, I'm going to turn things over to Tom. So Tom, if you want to take over from here.
Thank you, Amanda. Good morning and good afternoon, everyone, and thank you for attending our webinar this Friday morning. Before I get into the webinar, I'd like to jump into the core presentation. I'd like to speak a little bit about Iconix. I'm sure there are several here that are already quite familiar with Iconix, and thank you for spending the time with us again. And for those that are not familiar with us, or have perhaps in need of an update on some of the many exciting things that Iconix has been doing, thanks for attending. Iconix, headquartered in Foxborough, Massachusetts, has been in business for over 30 years. And throughout our history, we have developed leading-edge software tools encompassing dashboards, development, and automation solutions for a wide range of industries. As we've worked in these industries, we have continued to refine our software development skills to provide the best-in-class solutions for data visualization and energy analytics. Along the way, we have been a long-time partner with Microsoft. This relationship has proven to be invaluable in getting advanced access to cutting-edge technologies and new innovations to lead dashboard and visualization encompassing digital twin technology development. We have taken that product and industry experience and invested it into building a global partner network of over 400 partners residing in over 100 countries and over 375,000 installations worldwide. In August of 2019, Iconix became a part of the Mitsubishi Electric Group, serving as their automation software innovation center, in parallel to continue to operate as an Iconix entity and as a member of the Mitsubishi family. Iconix has over 3 decades of experience in providing state-of-the-art automation software solutions for a wide array of applications in multiple industries around the world. Whether requirements dictate an on-premise solution, cloud-connected solution, or a hybrid solution encompassing both on-premise and cloud, Iconix software enables system integrators, end users to create customizable digital transformation solutions specific to the application requirements. Today, we're going to talk about connecting to the cloud in our journey. Cloud migration can be a complex and disruptive challenge for any company. The move to the cloud has changed all aspects of the application development cycle, security being foremost among them. Security and DevOps teams face a growing number of entities to secure as the organization adopts cloud-native approaches. Ever-changing environments challenge developers to build and deploy at a frantic pace, while security teams remain responsible for the protection and compliance of the entire lifecycle. Cloud-native architectures are made up of cloud services, such as containers, serverless security, platform as a service, and microservices. These services are loosely coupled, meaning that they are not hardwired to any infrastructure components, allowing developers to make changes frequently without affecting other pieces of the application or other teams' members' projects, all across technology boundaries, such as public, private, and multi-cloud deployments. So in short, cloud native refers to a methodology of software development that is essentially designed for cloud delivery and exemplifies all the benefits of the cloud by nature. So to understand the journey, we first need to understand the primary components of an IoT solution. So with this block diagram, we see that there are four basic foundations of an IoT solution is comprised of four major components. We have edge computing, the cloud platform, the IoT platform, and IoT applications make up the solution. The edge serves as the bridge between the real world things, connected assets, the hardware layer sensors, actuators, PLCs, building controllers, and so on, that are collecting the data and utilizing the network in the cloud. It is where the digital transformation process is accomplished in order for cloud services to receive and act on the data. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it's needed. The most important benefit of edge computing is its ability to increase network performance by reducing latency. Since IoT edge computing devices process data locally, the information they collect doesn't have to travel nearly as far as it would under a traditional cloud architecture. With scores of protocols, connectivity models, energy profiles, and security requirements, and highly dispersed nature of IoT systems, the edge computation is needed to transform data, aggregate it, translate it, manage, and control these complex environments. The cloud platform is the hardware and operating environment of a server in an internet-based data center. The system software components include the underlying operating system and virtual machines and software-based cloud services, all combined to make up the cloud stack. Components of the cloud stack are a set of general purpose PaaS services, platform as a service, used by developers to develop cloud-based solutions. These services include messaging, storage, compute, security, and more. Cloud platforms such as Microsoft Azure also include analytic services and IoT services. The IoT platform is a set of IoT-specific platform as a service and software as a service services and development tools to facilitate the development of IoT solutions. They are usually developed on top of a general purpose cloud platform, which takes care of the security, scalability, reliability, and performance of developed solutions. The IoT applications are the user-facing components of the IoT solution. Users interact to visualize and manipulate the IoT data, extract insights, and make decisions or execute actions based on these insights. There are usually multiple IoT applications for a given IoT solution, each tailored to specific users and use cases. So we take this platform and overlap it with the Iconix integrated solution, and you can see that the core components of Iconix fit right into the architecture. At the edge, we have the Iconix IoTWorks Edge solution, which is a micro-SCADA platform specifically designed for cloud delivery, comprising of cloud-native architectures in the form of Docker containers, bringing the power and benefits of cloud services down to the edge and utilizing the Azure Edge runtime environment to manage and communicate between modules resident within the IoT Edge and between the IoT Edge device and the cloud. And I'll get in detail on the IoTWorks architecture later in the presentation. We utilize the Iconix Cloud Platform consists of Microsoft Azure Cloud Platform and services, including Azure IoT Hub, Azure IoT Provisioning Services, and Azure Virtual Machines and Databases. The Iconix IoT Platform consists of Iconix Platform Services in our Genesis 64 HMI SCADA software suite based on Microsoft's 64-bit operating system hosted on virtual machines deployed in the cloud. And IoT applications can Users can leverage our standard Iconix apps in the cloud, such as Genesis 64, Hyperhistorian, Analytics, Mobile HMI, and more. Also, Microsoft Azure services such as Power BI and machine learning can be integrated to provide greater depth of analysis. So by utilizing the partner ecosystem, Iconix can deliver a fully integrated IoT solution. So let's talk about IoTWorks. IoTWorks is our software suite developed provides a bridge between our on-premise communications network and a cloud-based communications network. An integrated micro SCADA software platform implemented as a software layer on top of an existing IoT gateway or industrial PC, transforming traditional edge hardware into intelligent edge devices. The IoT software platform is comprised of 11 components in the form of Docker containers that all work in conjunction with one another as well as independently. These containers are lightweight versions of traditional Iconix modules and are designed to provide efficient device connectivity, edge analytics, and secure data transfer to the cloud platform. So let's take a typical solution. So an on-premise solution. For end users, the journey to the cloud is ignited by the integration of the IoTWorks Edge solution into a customer's existing on-premise solution. So as we all are familiar with an on-premise, we have our things, our physical world connected to devices, gateways, PLCs, across a local area network infrastructure, integrating with the application server that is either located in the data center within the building, within a server on the factory floor to local clients. But once we add IoTWorks, the solution changes complexity immensely. With IoTWorks, ensuring the protocol translation and data bridge at the edge, we can translate and transfer data in between systems operating with different communication protocol, storage and forward capability. So we can store data up to 7 days on the edge gateway and have a scheduling to forward it to the cloud accordingly. If we lose intermittent connectivity, such as cellular communications, we do not lose the data. The data is still stored, and we can forward that data to the cloud once we regain network connectivity. Management. So we're utilizing the Azure device provisioning services to provision and manage our gateways, and we have a secure, all the data is sent over to the cloud utilizing secure transport protocols. And once it gets into the cloud, you have the Iconix applications in the cloud, which are ready to subscribe to the IoT Hub and ingest the data provided by IoTWorks. And so all this together makes IoTWorks a perfect fit for edge to cloud applications and taking advantage of the Microsoft Azure IoT suite. IoTWorks, one of the key benefits of IoTWorks is accelerates the OT and IT convergence. Operation teams are turning to edge computing, which gives them real-time access to mission-critical data at the plant level, while also sharing that knowledge throughout the enterprise. This enables rapid decision-making that improves safety and prevents costly downtime, while also sharing information across different plants and different geographies. Predictive maintenance. Technologies allow manufacturers to collect real-time data from the actual machine affected, monitor for any situation that might indicate a potential equipment failure, and then schedule repairs during planned downtime, while also extending the machine's useful life and dramatically reducing repair costs. Instead of using estimates or best guesses, these systems use real data intelligence for the factory floor. Cybersecurity is critical. For manufacturing, protecting intellectual property and customer information is paramount to a company's long-term visibility and viability and corporation reputation. At the same time, comprised production systems could affect quality, profitability, and even safety. In the enterprise, real enterprise-wide visualization on any glass, anywhere. So now all data can be shared within the factory floor up to executive management, and specific dashboards can be viewed based off of their use cases and requirements. There are many features that encompass IoTWorks. The key features listed here basically is secure transfer to the cloud via pub/sub methodology. Authenticate and provision devices by utilizing hardware devices in TPM. So the TPM, Trusted Platform Modules, are a cryptographic processor that are embedded into gateways, and it's the beginning of the security initiative on its journey to the cloud. Rapid provisioning and registration utilizing Azure's device provisioning services. Extend the power to the cloud to the edge device, encompassing key ingredients for successful cloud management. So why containers? Containers are compatible to virtual machines in the conventional architecture, but are native in performance and more reliable and lightweight, requiring less memory space. Each application in a container is an isolated piece of software. It is there to perform a dedicated task, and as a result, improves on failover management and load balancing. Container applications can be tested and shipped within a container, and therefore are not dependent on the hardware platform or the operating system related variables as in virtual machines. Containers improves workflow of application lifecycle development and testing, allowing the production environment based testing, and helps in rapid container deployment. So here's our block diagram of IoTWorks. IoTWorks platform consists of 10 iconic containers, which I mentioned before, plus 1 OEM container. So this allows our partners and OEMs to develop their own container and have the capability to deploy it within the IoTWorks platform. Secure cloud connectivity containers at least one device. Briefly, the Docker containers. We have an IoT communicator, which is our data translator. Our hyper collector, which is our store and forward capability, is a subset of our hyper historian in the cloud application side. We have our IoT Analyzer, which is our fault detection and diagnostic capabilities. Our Visualizer. So user-defined dashboards can be visualized and viewed at the edge on any standard device, monitor, smartphone, or tablet. And our IoT Connector, which is the secure transport of the data from IoTWorks up to the cloud, supporting the standard protocols, MQTT, AMQP, REST, HTTPS. And what we've got recently added is our integrated MQTT broker. So customers utilizing devices that support an MQTT client can easily connect those devices, sensors, etc., to IoTWorks, and the IoTWorks MQTT broker can grab those the messaging in the device packet and translate that and send it upstream either through AMQP or MQTT to their cloud services. So what I wanted to do is just to go through the provisioning services of Azure. I think this is very important in both one of the key features of IoTWorks itself, as far as hands-free provisioning. So initially, when a customer gets an IoT device, what they will do is plug it in. And when they plug it in, and before that, they want to set up, their Azure account with their IoT Hub, their device provisioning services, as well as a Docker Hub container registry. Then they want to load the Edge Gateway, so the Azure Edge runtime, onto the gateway. Or they could have this already preloaded from one of our partners when they buy or purchase the gateway itself. From then, once it's plugged in, the device connects to, after the OEM has registered, and this is probably done beforehand as well, we'll register these devices based off the cryptographic TPM module. The device automatically connects to the Azure IoT cloud via the Edge security daemon. From there, the device gateway says, okay, guys, here I am. This is my ID. From the enrollment list on the Azure cloud, that ID is validated to the enrollment list itself via the TPM and in a certificate. And it says, okay, let's see where I see you guys. All right, you're valid, and that continues. So then the device is registered, the device's twin, is registered to the IoT Hub. The IoT Hub returns the device ID back to the DPS provisioning services. This is critical. Then the device returns the IoT Hub connection string into the Edge agent, which is basically the manager of the containers within the platform. From then, now bi-directional communication begins from the IoT Hub to the device. And then the device receives the configuration from the IoT Hub, which is the device twin. And then from Workbench in the cloud, the end user configures the containers and how IoTWorks is being set up, selecting which containers they want to utilize, and configuring and doing the custom configuration of the container. And then when the configuration is complete, the containers remotely get deployed onto the IoT Edge device itself. And pretty much all this is automated after you basically plug it in from the, and the tunnel gets created from the Edge security daemon to Azure Cloud. We can also support manual provisioning. The key feature in manual provisioning is that the end user provides the IoT Hub connection string manually. Customers still like to do manual provisioning. They may not have as many devices deployed in the field. They don't have viable connectivity sometimes in the field where they need to go out, for instance, upstream oil and gas, and provisioning the gateways manually. So let's get into some of the components of what is, the IoTWorks containers. The IoT communicator, universal support of universal connectivity. The IoT communicator handles the real-time connectivity to open protocols. These are the same protocols that a standard Iconix product support, including OPC, UA, BACnet, Modbus, SNMP, as well as our integrated MQTT broker, which I previously discussed. Each of these protocol connectors can be configured as appropriate from the cloud in the device provisioning side of things. And these modules allow for real-time publishing of data from the defined point list. Next, we have our IoT Collector. The IoT Collector is for asynchronous data collection, where there may be higher volumes of data of information that is not crucial to publish live. The collector then also leverages the store and forward buffering and is quite flexible to overcome network interruptions or limited bandwidth. It is possible that value may be published live as well as being collected and logged. Each can coexist and for different uses. Data is not lost when there's intermittent network connectivity. The collector has the ability to store data messages in packets, and utilizing a built-in scheduler can publish that data to the cloud once connectivity is regained. Iconix hyperhistorian in the cloud as a subscriber will be able to consume the data packets. Our fault detection and diagnostics, edge analytics. The IoT Analyzer can be incorporated in a couple of ways, both centered around providing opportunities for edge analytics. The new workflow engine has been including, allowing for real-time monitoring of events to trigger workflows or actions. These workflows can be monitored from the cloud and provide an efficient means of boiling down information to make for a more efficient communication. Also, the fault detection and diagnostics engine has been designed to integrate to the gateway device and offload fault monitoring when possible. The benefits here are twofold. It improves the efficiency of data transmission, as many of the data sources integral to the fault detection engine can be sourced on premise, and it increases the rate at which faults can be detected on premise processing as opposed to later on in the cloud, and will catch issues faster, hence latency. We drastically decrease the latency issue, and we can see issues real time at the edge with IoTWorks. This is huge for IoTWorks in general. We take very serious the security capabilities for the entire journey of the cloud. Excuse me. So it begins with the IoT Gateway. When we spec our gateways with our partners, we try to only select gateways that encompass a trusted platform module. The trusted platform module is a cryptographic processor that is built into the gateway that is the unique ID generator for a gateway to identify itself to a cloud platform. And it does that via the endorsement keys or a shared access signature. Once that then we have our secured cloud transport protocols, AMQP, WebSockets, MQTT, MQTT over WebSockets, HTTPS, as well as MQTT. The connection security utilizes certificate handshaking and data encryption. So all this data is TLS encryption traveling over the network and to the IoT hub or other connectors within third-party cloud solutions. But with Azure, we utilize the Azure Active Directory key fault and policy-based control. So as you can see, from the edge to the cloud, in each step, we have security measurements being undertaken. So the IoT Visualizer, it's a self-serving dashboard. The Visualizer is able to, customers are able to develop dashboards literally on the fly. that meet specific industry needs and specifically user needs while interacting with displays in runtime. So with our visualizer, we could actually even replace PC panels on the factory floor with standard monitor products, utilizing smart devices such as tablets and iPhones. It's a secured scenario where the user will type in the IP address, the gateway. There is credentials that are required, so it's secured, so not everybody can just log on. And then they could view existing dashboards that are already there, and on the fly, within a palette that within the IoTWorks platform, they can actually develop, their own dashboard right then and there by utilizing bringing from the project the tag over to a widget, putting it into the widget, and they created a dashboard. The IoT Visualizer is key for the OT groups as far as being able to have mobility and flexibility of data visualization and seeing the data real time. So from edge to cloud, scalable edge computing. IoTWorks, bringing the intelligence from the cloud to the edge real time with minimal latency, scalable edge computing with on-premise visualization of the KPIs. The IoT ecosystem. So we feel, Iconix feels that no one company can really do justice in putting together and supplying all the integral components that are that it takes to make up an IoT solution. So by utilizing the IoT ecosystem, enable users to construct IoT solutions that are made up of a number of parts, which can often be separated and sold on their own, for example, as applications, but that together comprise a comprehensive outcome-based IoT service that is usually and mostly adapted to individual organizational needs. So basically utilizing the partner ecosystem to truly drill down into what your requirements are is the optimal solution. So to provide compelling products for IoTWorks, Iconix has gone out to partner with several best-in-class companies in the hardware and software spaces. And for today's webinar, we have highlighted products from Advantech to demonstrate how easy it is to connect the physical assets to the cloud utilizing Advantech's IO modules as well as IoT gateways. So with that, I would like to pass the reins over to Nathan Smith, Senior Director of Advantech, so he can discuss the offerings and capabilities of Advantech products.
Okay, so I will put my screen up. So thank you, Tom. I appreciate your introduction and your working with Advantech. And I appreciate the opportunity to present our various IoT computing products. I think working with Iconix allows us both to provide some device to cloud solutions for a variety of different applications here. And some of you may be familiar with Advantech as an industrial PC company. We've got a whole range of industrial PCs from rack mount chassis to panel PCs, embedded fanless PCs. We do IO products, Ethernet switches and things. But in this particular application, we want to stay focused on our edge gateway solutions. And that's what I'll be talking about in the next couple of slides coming up. But a quick little slide here that sort of talks about the whole, say, industrial PC market and the industrial IoT gateway market in particular. This slide's a little bit dated, but I still nonetheless think the data is relevant, that the market for industrial PCs is growing and the industrial IoT gateway itself is growing tremendously. So we see a big growth in this whole space, continuing through 2020 and beyond for the next several years. And Advantech, as one of the largest players, in fact, we are by far away the largest industrial PC manufacturer in the world. We're well positioned to provide a range of edge computing platforms. So let's take a look at a couple of platforms that we have that we're developing with Iconix here. You might sort of say we're working on a range of platforms to support the IoTWorks framework that are sort of good, better, and best, sort of 3 different levels there. And if we take a look at whoops, sorry, I got ahead of myself there. If we take a look at these different levels here, down at what we call the good level, we'll say, that's a single core Atom processor running in there that has RAM built in. It's got solid state drive built in, as all these devices do. And then we move up to the mid-range level, the UNO 2372, which is running a quad core Atom. And then we move up into the higher end version running a quad core Celeron. That's the UNO 1372. Which is also available in a class 1 Div 2 version for anybody who's doing work in the oil and gas space. That's a good gateway to be working with. And these units will either run Windows or Linux, 24-volt operation. Again, they're all fanless devices. And I guess that thing we definitely want to highlight here, as Tom mentioned earlier, is they all support TPM 2.0, and that's that trusted platform module technology. And it's designed as a hardware-based security chip, and that chip provides secure processors embedded onto our hardware, and it gives you an extra level of security out there at the edge. So it allows for authentication of the device at the edge, and then enables more secure communication with your cloud devices. So this just gives us a greater level of security out at the edge. So we have these 3 products, and depending on your implementation of your gateway, you would decide how much horsepower do I need out at the edge to run my IoTWorks application, and how much I/O am I talking to, and how am I networking things. So those are the 3 gateway products we have, and then we have some additional expansion capability for these devices. In a communication wise, we offer a series of what we call our IDOR modules. And so these allow you to expand the communication within each one of these gateways. For example, if I wanted to expand my PLC communications, I could pick an EtherCAT IDOR module. I could pick a Profinet IDOR module. And this allows me then to have the communication protocols in there to communicate with that bus network. And I can also expand just on my communication connectivity, whether I wanted to add Wi-Fi to one of these devices, or if it was really a remote edge device, I could add a cellular capability to these devices. So there's different ways that we can expand communication besides what we get out of the standard package, which of course has USB on it, it's got Ethernet on it, it's got serial on it. So there is a lot of communication right from the beginning. So those are our gateway products, and if we were to fit those into the bigger picture of our whole device to cloud scenario, I think way at the device end, you almost have a pure hardware play, and Advantech has quite a few I/O devices that we can use down there, whether they're wireless or wired devices. We're talking Modbus, we're talking MQTT down at that level. And then we go up into the edge computing level, which we already discussed a couple of our gateway products that we can stick in that space. When you get into the mobile aspect of it, certainly the Iconix software works on any glass, and Advantech has a variety of glasses. And in the mobility world, we've got a couple tablet PCs that would fit into this space quite well. And then when you get up into the full-blown Genesis version of software, you can run that on our higher end servers if you so choose. And then, of course, at that point, you're moving into more of the pure software play up in the cloud area. So the idea here is that Advantech is providing the hardware platforms that work with the Iconix solutions to create the whole device to cloud scenario. And I want to touch a little bit on some of the IO products, because I believe we have a demonstration coming up that's using some of our Wi-Fi IO modules, but I just wanted to let you know of some of the other wireless technologies Advantech has out there. Of course, we've got Wi-Fi modules that are talking analog and digital inputs. We have a smart mesh network, which is like a redundant network of analog and digital inputs. We have the new LoRa technologies out there, LoRa WAN technologies. We have that also as a Wi-Fi, as a wireless communication technology. And we have a range of cellular technologies as well, including some of these new narrowband IoT and Cat M1 solutions. And those ones are actually so inexpensive to deploy now. You can actually have your IO built into your cellular device and have it communicate as almost like an IO module. So that's the family of wireless products that we have to offer here as well. So we're crossing all these different markets and different technologies. And then we have our more traditional, if you're familiar with some Advantech product, the Atom IO that talks serially, or Modbus TCP that you can do all your data collection with. And those, again, talk MQTT and will support all the IoTWorks programs. So that's essentially a quick overview of what Advantech's doing as far as the gateway solutions. You know, we have a couple of hardware products in there and some of the IO devices, and then that feeds up into the IoTWorks and up into the cloud. And so I guess at this point, we can pass that along to Arga. Do you want to do your demonstration and take over the control of this?
Thank you, Nathan. Great stuff. So in summary, hybrid solutions for digital transformation, edge and cloud. Deploy on-premise and the cloud are both, maximizing operational excellence with deployments that specifically address your IoT business case and IoT strategy by starting with achievable projects with a defined return and easily scale as your requirements expand. Hybrid approaches utilizing edge computing in the cloud will enable process and discrete end users to provide actionable information to support real-time business decisions, support of asset monitoring, data analytics, process alarming, and process control, as well as machine learning in the emerging AI ability for machines to make capabilities from both edge and cloud computing are migrating into the gateways and edge devices for all IoT networks. At this point now, I'd like to introduce Bhargav, and he will go through the demonstration of connecting IO devices via MQTT to the IoT Gateway and up to the cloud.
Thank you, Tom. Let's take a moment to take a look at the architecture and the hardware that we have set up in our demo today. As mentioned before, we're using the Advantech WisePass to convert all of the input-output signals that we collect from various devices on a board to convert it to MQTT messages that are published to IoTWorks that's running an MQTT broker, and the IoTWorks gateway publishes that data up to the cloud for overall visualization over the world. We also have local visualization capabilities right on the IoTWorks gateway and is accessible on the local network. Let me start sharing my camera feed and also change the view of the presenter to a tablet that we have on the same network. If you notice here, on the left side, we have the primary fan, primary dryer, which is emulated by this fan. We also have a secondary fan, which is being emulated by a motor. We have two WisePasses that are collecting the data from these input-output values and publishing it over to the gateway that is sitting right there. We have push buttons and status indicator Stacklight also available for the operator's ease of use. The WisePasses are connected over Wi-Fi to a router sitting right behind the gateway, and the gateway is wired into the router for high-speed internet connectivity. Now, we also have a tablet connected to the same Wi-Fi router So it's able to access the gateway's IP, where we could start taking a look at the various dashboards available on the gateway. As you can see, I have the IP address of the gateway bookmarked on a web browser. This is to show the fact that we could access these dashboards from any device, no matter what type of device it is. So let me log into the graphic. You can see I have the primary dryer speed and the secondary dryer speed reading in real time. We also have a Stacklight indicator digitized onto the graphic. We have the bad product and good product counts as well. Tom, could you please increase the good products count by hitting the button? As you can see, the good products count has increased as Tom was pressing the buttons instantaneously. Now, Tom, could you also change the bad products count? That's 17. Thank you. We also have a historic trend locally available on the graphic, which records the primary dryer and the secondary dryer's RPMs. We also have a workflow that is running right within IoTWorks, which is able to do a switchover or a failover on a set point. Let's simulate a fault on the primary dryer by slowing it down physically. Tom, could you reduce the speed on the primary dryer, emulating the fact that we have a failure on the primary? As you can see, when the speed of the primary dryer goes off, the secondary dryers kicked in, and the status indicator is also showing the status correctly. This is what we call a fault. And if you see, we have a fault that is showing up on the screen that the primary dryer or the motor is slow. Now, Tom, could you switch the primary dryer back to full speed? Now you can see there is only one fault on the screen that shows that the secondary dryer is slow. This gives the user or the operator real-time feedback of what the status is or what the fault is on site. Tom, could you switch the primary dryer back to slow, emulating a fault on it? And now you could see the primary dryer's fault is showing up, and we've given it a higher priority, so it shows up in red with the level of 900. This data is locally available and can also be published to the cloud. Now let's take a look at the cloud dashboards. And I'm going to switch over to the cloud dashboards. For accessing my cloud dashboards, I am going to open a web browser and punch in my URL, which brings me to my cloud dashboards. And as you could see, we have a historic trend of data that is publishing values to the cloud. We not only have command and control from here, I can reset the bad product count, for example. We have a publishing rate of about 10 seconds, and you should see that we will reset the bad products count from the cloud. And we have the status of the fans being indicated. It is showing me that my primary fan is on right now, and I just reset my bad products count. Now, when the failover happens, which let's try to emulate for us, Tom. You could see with a short delay, our graphic is also going to notify us that there has been a failover to the secondary fan. As you can see, this trend has also transitioned, and you also have real-time KPIs of the statuses of your dryers. Now let's take a look at how this is configured. And I'm going to stop sharing my webcam. This is my cloud where I have Genesis 64 installed. If you've used Genesis 64 before, this is a workbench where you would normally have a local project, but because we're using IoTWorks, In addition to that, we also have a cloud project. Under the project, you have a group of devices that are connected with your IoT hub. As you could see, I have about 3 devices online, and this particular Advantech Uno is the one that I'm currently demonstrating with. We have device templates where you can modularly attach a template to a particular gateway, or you could also use the same template for multiple gateways. Currently, I'm using the Advantech Gateway config. As you can see, I have a published list with a list of faults that I've defined, and I also have my MQTT brokers configured with just within the UI. All I need to do is add the name of the broker and deploy my configurations, and that deploys our Mosquito broker on the gateway. To understand any MQTT message, we have what we call encoders or decoders. Let's take a look at an example of one of the decoders that we're using on the Advantech WisePass. If you've used JSON before, this is a standard JSON notation. We have a key value and its value pair. We associate key values with keywords that allows IoTWorks to understand what that key value is associated with. For example, T is the key value pair, and the timestamp text is the keyword associated with that key value pair. We have Q, which is associated to OPC quality of the data. And by simply configuring one encoder per type of message, we are able to understand any JSON message format that is published by the MQTT IO module or the sensor. With a click of a button, I could also restart my modules on the gateway from the cloud. And another click of a button starts the project deployment, and it reaches down to the gateway. That's it from me.
Thank you very much for that informative presentation. Let me switch to my screen here and show you my conclusion slides. Okay, and now I'd like to talk to you about the Iconix Worldwide Customer Summit Transform 360. We recently rescheduled this in-person event to May 4th through 7th, 2021 at Foxwoods Resort and Casino in Connecticut. If you already signed up for the event and you'd signed up for the previous dates, we've just moved your registration already to the new dates, so no action needed on your part. If you haven't already signed up, I encourage you to do so. This event is going to be bigger and better in 2021. We have a number of exciting guest speakers lined up, as well as compelling demos to show you. If you register by April 19th, you can do so at iconix.com/transform360. We have a number of promotions that we put up on our social media pages from time to time, including complimentary registration promo codes. So I encourage you to follow us on social so you can see those and sign up. I really hope to see you all there at this live in-person event. I'd also like to share with you a number of on-demand webcast recordings that we have available at iconix.com/webcast. If you've enjoyed today's webcast, you can see the other topics that we have covered this year. And not only do we have these North American webcasts, but we also have a number of international versions as well. And I will leave this slide up here while taking questions. Just to remind you, we do have some other international webcasts that you can register for. If you are German, you speak German and you want to attend those, register for those. And then we encourage you to stay up to date with Iconix by joining us on our social media channels. And with that, I'm going to start diving into some of the questions here that have come in. So let me look at the first one here. So Tom, this first question I'm going to direct at you, and it's there's a couple questions within a question. So what device drivers are included in the IoTWorks gateway? If I'm putting an IoTWorks gateway in my system, I am likely going to remote any existing servers that may have existing OPC servers, such as Kepware. So I would have to make sure that the gateway can communicate with all my devices.
So sure. So in the instance where Kepware is being utilized, Kepware can reside on the same platform as the IoTWorks, and we can continue to utilize that via, if Kepware generates an OPC UA type packet so that the Iconix platform can read that device. But as mentioned, we support OPC UA, we support Modbus. These are our point managers. And we're also SNMP, MQTT, as well as BACnet. If there are device drivers that are proprietary, we can also address that by working with the customers so Iconix is capable of designing custom point managers to be able to read their data.
Okay, thanks, Tom. This next question I'll give to Bhargav. Can we use IoT Hyper Collector for storing and forwarding alarms also? And if yes, then is this alarm stored in the HHD files of Historian in the cloud?
The answer is yes, we can store and forward the alarms or the faults that are detected at the edge. They are stored in separate files, not with the Hyper Historian or the Hyper Collector HHD files, but they do have history on the local hard drive of the gateway.
Okay, thank you. Next question I'm going to give to Nathan. What is the storage capacity in the gateway?
Okay, sure. The gateways standard are going to come with about 64 gigs of solid state storage in them. But any of those three that I happen to mention there, we could expand those up to as large as 1 terabyte of storage in there, whether it's a solid state drive or in that smaller 2271, it would be an mSATA drive. So there's quite a range of flexibility in storage.
Okay, thank you, Nathan. And the next question I'm going to give to Tom here. Do we have any analytical software in IoTWorks for predictive analysis?
So with that, we utilize, our fault detection and diagnostics capabilities, so that because with our IoTWorks, our latency is minimized, we can detect visually aberrancies within the operation or whatever. We can mark those as events. We could alarms. We could also set alarms. All this data is collected and then sent up to the cloud. So once in the cloud, where it's within our Historian, we could work with, for instance, Azure machine learning for developing additional algorithms for high-end predictive maintenance algorithms that then can be ported back down to IoTWorks.
Okay, and I'm just going to, because of the time, I'm going to ask 2 more questions. For those of you that didn't get your questions answered, email us at webcast@iconix.com and we will answer you offline. So the next question, Bhargav, how are updates installed to IoTWorks?
That's a very good question. You typically, once the gateway is shipped down to the site, the IoTWorks installation is performed once, but after that, everything else is managed from Workbench. Like I showed earlier, with a click of a button, you could also update your containers to the next software version that's released out there. And we do plan on releasing constant updates, so you don't really have to be on site in person. It can all be done remotely using the cloud server.
All right, thank you, Bhargav. And last question, Nathan, you mentioned LoRaWAN. Why would you use that versus Wi-Fi?
Yeah, good question, and that could go on for some time. I'll try and make a short answer out of it. So LoRa is sort of a lower bandwidth sensor technology than the Wi-Fi is. Wi-Fi is good at streaming the video and doing audio, but LoRa is really about just pure data. So the bandwidth is much lower but for passing data, it's ideal for the kind of things we're talking about here in IoT and edge data collection. And the distance of LoRa can be up to about 5 kilometers, depending on antennas used and that type of thing. So it's great for remote applications. And another main difference with the LoRaWAN technologies, it does require a gateway. So you could have multiple LoRa sensing devices scattered around the facility, but they all communicate back to a gateway, and then that gateway will communicate to whatever SCADA system you wanted to communicate with.
All right, thank you very much. And thank you everyone for joining us today. We hope you enjoyed today's webcast, and be sure to check out Iconix.com for future webcasts. Thank you to Nathan and to Bhargav and Tom for presenting today. Hope you have a great day, everyone.
Thank you, guys.
Thank you.